The previous example considered a private value auction. That was an auction in which whatever was being sold was valued privately by the individuals who were going to buy it, so everybody could have different tastes, different willingness to pay. The example that I'm going to consider here is quite different. It's called a common value auction. The idea is that whatever is being sold has a common value, and it has a common value because it's something that's going to be sold in a market. So whoever buys it is going to sell it for the market price. So its value isn't set by individual tastes and willingness to pay and so on. It just depends on what people think its market value is going to be. It follows that if everybody had perfect information about the thing being sold and about its future value, then everybody would have exactly the same value. Everybody would be willing to pay exactly the same amount for it. That's what the term common value means. It means that everybody would have the same valuation for it, that it would be in common. However, in reality, people don't have perfect information, and that's going to make an important difference, as we'll see. Let's consider a couple of examples. Suppose that we were going to auction off this jar of coins on the left-hand side. Nobody knows exactly the value of the coins inside the jar, but it does have a certain value. But obviously there's a lot of uncertainty surrounding that, so it's possible that some people could be overly optimistic about the amount of money in there. Some people could be overly pessimistic. So people would have different expectations and therefore a different valuation for what's in the jar. The same goes for the picture on the right, which is supposed to illustrate the idea of a pool of oil underneath the surface of the ground and an oil well that's going to be pumping up that oil. So everybody knows that the oil is going to have some future market value, but nobody knows just what that might be. As well, typically, geologists might try to estimate how much oil is under the ground, but that's going to be uncertain as well. So if this was going to be sold, the participants in the auction would face a certain risk. You might be too optimistic about the amount of coins in the jar or the amount of oil in the ground, and you might end up bidding too much. This is what is called the winner's curse. So you might win the auction by paying a high price, but you may have ended up paying too much. Just to give you an example, possible example, here's a picture of a bluefin tuna, an endangered fish, which sold for $3 million in a fish market in Tokyo at the beginning of 2019. The man standing behind the fish is the owner of a large chain of Japanese fish restaurants, and he is also famous for paying the largest amount for a fish in the first auction of the year in this fish market in Tokyo. Did he fall victim to the winner's curse? Well, according to the report I read, he said after the auction, "The tuna looks so tasty and very fresh, but I think I did too much." So he probably got carried away and paid too much for the tuna. I might add, beforehand, in these auctions of fish in this fish market, people are allowed to inspect the tuna, and a little cut is made in the fish, and they can examine the nature of the flesh to see what its quality is. So, how do bidders deal with this winner's curse problem? Here's the basic problem. Suppose people have valuations that are illustrated by this diagram here. Let me just explain what this picture is saying. This is on the horizontal axis the valuation that individuals are guessing that the object that's being sold has. So there's going to be somebody, let's say this person here, who has the highest estimate of its value. There's going to be a lot more people who have some estimates in this range. So the vertical axis here is effectively showing us the proportion of people who have these particular evaluations. So this is saying that on average people are going to guess correctly. And so this is the actual value of the item. So if everybody had perfect information, then that would be their valuation. 100% of the people would think that that was the value, and there would be no real interest in this auction. Everybody would know its price, and in fact the seller could just sell it for that price, and that would be it. There'd really be no need for an auction. So the problem here is that if people bid the amount that they estimate its value at, the winner of the auction is in fact going to face the winner's curse. So, as I note here, bidders can't confuse their estimate of its value with its actual value. They have to realize that they could be making a mistake. So the essential idea is that somebody who has a high valuation like this one here is going to have to realize that if he or she wins the auction, they're very likely to lose, in the sense that they will be paying too much. So what they really need to do is to figure out what they should actually bid. So they shouldn't bid their actual estimate of its value. They should bid something less, something that they're going to hope is going to be closer to the actual value of the item. Well, one way to deal with that, as I just said, is to make some sort of adjustment to the bid. So what you could do is something like this. Suppose that this, again, bell-shaped distribution shows people's estimates of its value, and this distribution here shows the bids that they would actually be willing to make based on their estimate. So suppose that this person here has the highest estimate. They want to adjust their bid downwards by some amount, hoping that they're going to be hitting on the actual true value of the object that's being sold. Well, everybody is going to do the same, and we can imagine that this distribution of estimates just gets moved to the left, and that this would reflect people's actual bids for this object. How much of an adjustment should you make? Well, you might want to consider how good or how bad is the information that we have. the information that we use in order to estimate its value. If it's very uncertain, then we should be much more cautious. We'd also want to ask, how many bidders are there out there? So, for example, if there's a very large number of bidders, and you are the one with the highest estimate, that should worry you, because everybody else, a very large number of other people, have thought that it's worth less than you think. And therefore, it would seem that your chances of falling victim to the winner's curse would be greater. Unfortunately, there is no simple formula that can be applied. Really, some judgments have to be made about how much the bids should be adjusted downwards, as I've illustrated here. So, just to sum up, when we're thinking about a common value auction, the winner's curse is something that really must be considered very carefully when a firm decides on what its bidding strategy is going to be.